Another substitution example might feel a little excessive, but this problem is a little bit different, and I want to illustrate this type of substitution that's going to happen here. So really, there's not a lot of options when we look at this integrand. There's an x and there's a square root of 4 minus x. So we could try, u equals the square root of 4 minus x, but the derivative there is going to be horrible, and I don't really want to have to deal with that. So we're not going to do that. Instead, we're going to try u equals 4 minus x. And it's going to look like this is not promising at all. Du equals negative dx. We don't have just a dx, we have this x times dx. But let's start replacing things. Let's start substituting. And we get an x, and now I have a square root of u, and this dx is negative du, but I can't get it all in terms of u. There's that x in there. That's a problem. I want to be able to write my integral all in terms of my new variable, and I couldn't quite do it. I have this extra x floating around, and the substitution didn't help us with that. But what we did have was u equals 4 minus x. That was the substitution we made. And if we look at that and rearrange it a little bit, add x to both sides and subtract u from both sides, I have x in terms of u. So I can do it. I can go back and I can plug that value in for x. And we end up with an integral of 4 minus u times the square root of u times du, and I had that negative as well from the change of variables. So that now is an integral that we can do. We've successfully turned it into an integral involving u's and du's only. There's no more x's in there, so that's good. And it turns out that it became something that was doable, whereas it was not before. So 4u to the 1/2 minus u to the 3/2 du. We use a power rule on this. The integral of u to the 1/2 is, so we've got a negative 4 times 2/3 u to the 3/2. Negative and negative is a positive, so we have a plus 2/5 u to the 5/2 plus c, and u is 4 minus x. So we have negative 4, well, 2/3 times that is going to be negative 8/3 times 4 minus x to the 3/2 plus 2/5 times 4 minus x to the 5/2 plus c. That is our antiderivative. And that's a substitution that's a little bit trickier. It's not immediately apparent from the integral what should be substituted, what we should use. Even after we make the right substitution, it looks like things are not going to work out. And we have to do a little bit more to kind of push it through and get everything written in terms of u, and then we can take the antiderivative.